Hello, students. Today, we are going to look at a very important topic, which is the physical properties of salt. Physical properties of salt. Physical properties of salt. Just as we discussed in the last video, salt is formed when acid reacts with base or alkali. It will give us salt and water. When acid reacts with base, it will give us salt and water. The reaction is known as neutralization reaction. Neutralization reaction. The reaction between acid and base to produce salt and water is known as neutralization reaction. Now let's take, for example, of acid here to be hydrochloric acid reacting with a base, let's say sodium oxide. That will give us sodium chloride and H2O. H2O. All right? Here is the compound. All right? The acid reacts with base, gives us salt and water. The same acid here can also react with this alkali, sodium hydroxide, to give us 1 mole of sodium chloride and 1 molecule of water. It will still give us the same product. All right? The reaction is known as neutralization reaction. So this is a typical example of salt. All right? But I want us to look at the physical properties of salt in this video. What are the physical properties of salt? Number one, we are going to look at what is called efflorescence. 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 This is what we're going to look at now. All right? Some salts contains water of crystallization. Some salt contains water of crystallization. Such salt is known as hydrated salt. Such salt is known as hydrated salt. Salt that contains water of crystallization is known as hydrated salt. While salt without water of crystallization is known as anhydrous. Salt without water of crystallization is known as anhydrous. Now, efflorescence. Anytime you hear the word efflorescence, we are looking at hydrated salts. All right? Now, let's look at efflorescence. Like I told you, if we are talking about efflorescence, look at the salt we are looking at. Hydrated salts. The one that contains water of crystallization. All right? Now, efflorescence here is the phenomenon whereby hydrated salts loses its water it loses its water of crystallization to the atmosphere when exposed. All right? Efflorescence is the phenomenon whereby hydrated salt loses its water of crystallization to the atmosphere when exposed. Remember, hydrated salt is the salt that contains water of crystallization. Now, let's give examples of these hydrated salts. We have example as this. All right? Sodium triisocarbonate decahydrate. Copper 2 tetraodosulfate 6 pentahydrate. Then we have this one. Iron 2 tetraodosulfate 6 heptahydrate. These are examples of hydrated salts. Now, effervescence is telling us that these hydrated salts here will now lose some or completely of this water of crystallization to the atmosphere. All right? Effervescence is a phenomenon whereby hydrated salt loses its water of crystallization to the atmosphere when exposed. Take note, it loses this water of crystallization partially or completely. All right? They loses the water of crystallization partially or completely. Don't forget that. Now, look at the illustration that define what we have here on efflorescence. Exposure to air. Just expose the salt to the atmosphere, it will lose the water of crystallization. We are going to have it like this as the product. Here, it loses the water partially. All right? It loses the water of crystallization partially. 9 molecules of water is lost. All right? While one remains here with the salt. Now, secondly, we have copper 2 tetraodosulfate 6 pentahydrate. On exposure to air. All right? It's going to have the product here. Copper 2 tetraodosulfate 6 and 5 molecules of water being lost. Shows that it lost the water of crystallization completely. Now, when these salts, hydrated salts, loses its water of crystallization to the atmosphere, the salt will lose weight. All right? The salt loses weight. When the hydrated salt loses its water, of crystallization, it loses its weight. It loses weight. The salt loses its weight. All right? When the hydrated salt loses its water of crystallization, the salt loses its weight. All right? Then, such salts are known as efflorescents. Such salts, such salts or compound are known as efflorescents. Okay? The compound that loses its water of crystallization to the atmosphere when being exposed. Like I said, they are known as hydrated salt because this is the salt that contains water of crystallization. All right? But this compound here that loses its water of crystallization to the atmosphere when being exposed, they are known as efflorescent. And like I told you before, when they loses this water, the salt automatically will lose its weight. Don't forget, they lose this water of crystallization partially or completely when being exposed to the atmosphere. So this is the number one physical properties of salt. Let's look at the second one. Secondly is deliquescence. What is deliquescence? All right? Now here, deliquescence here, we are talking about anhydrous salts. All right? These physical properties here, we are looking at anhydrous salts. These salts here don't have water of crystallization. They are very dry. All right? Rather, when they are exposed, they absorb water. They absorb moisture. All right? And because they absorb water or moisture, they serve as a drying agent. Do you understand? They serve as a drying agent. Now, the deliquescence here is the phenomenon whereby some compound absorbs moisture, or gases from the atmosphere. From the atmosphere. From the atmosphere to form a saturated solution. A saturated solution when being exposed. All right? Some compound, usually anhydrous compound, absorbs moisture or gases from the atmosphere to form a saturated solution when being exposed. All right? Such compounds are said to be deliquescent. Then the phenomenon is known as deliquescence. Is that okay? All right. Such compound are known as deliquescent compound. All right? They are known as deliquescent compound. All right? Now, the deliquescent compound here, the compound gains weight. As they absorb moisture from the atmosphere, they gain weight. All right? The compound gains weight as they absorb moisture from the atmosphere. From the atmosphere. All right. Example: sodium hydroxide and potassium hydroxide. They are the liquescent alkali. All right. Sodium hydroxide and potassium hydroxide are the liquescent alkali. Then others like calcium chloride, we call it anhydrous. Anhydrous calcium chloride salts, iron 3 chloride. All right. Are the liquescent salts. Okay. All right. Now, this compound, these compounds are used as drying, they are used as drying agents. They are used as drying agents. All right. Take note, they gain weight as they absorb moisture from the atmosphere. All right. The next we are going to look here is hygroscopy. That's number 3 physical properties. Hygroscopy. All right. Just as the liquescent. Hygroscopy here is the phenomenon whereby some compound absorbs moisture from the atmosphere without forming a solution. Without forming a solution when exposed to air. When exposed to air. All right. Such compound are known as hygroscopic compound. They are known as hygroscopic compound. All right. All right. The compound gains weight, such as we have here in the liquescent. They gain weight when they absorb moisture. They absorb moisture and gains weight. All right. They are also used as a drying agent for water or gases. They are also used as drying agents. The compound are used as drying agents. All right? They are used as drying agents. All right. All right. Now, let's look at examples of hygroscopic compound. All right? Examples of hygroscopic compound. Examples of hygroscopic compound. We have copper oxide. We have calcium oxide, the quicklime. We have H2SO4. All right? H2SO4, calcium oxide, copper 2 oxide. All right? These are typical examples of hygroscopic compound. All right? But take note here. We also have phosphorus 5 oxide, all right, as the liquescent oxide. Remember, this one here are the alkali, all right? So phosphorus 5 oxide is a typical examples of the liquescent oxide. So here, copper 2 oxide, quicklime, which is also known as calcium oxide, and tetraoxosulfuric acid are examples of hygroscopic compound. This compound absorb moisture from the atmosphere without forming any solution. All right? Whenever they are exposed, they absorb moisture without forming a solution. And like I told you, they gain weight when they absorb this moisture from the atmosphere. And as such, they are used as drying agents. All right? So that's all we have for now in this video. Please make sure you subscribe to our YouTube channel. Drop your questions in the comment section. Like the video. Thank you and God bless you.